Okay, here we are, 812, starting you off with an intimidating problem, but then after we dig through it, you're going to find out that it's not that bad. So here we go, 812. Starts out with this graphical sort of description of somebody that's using a yo-yo. I don't know if you've ever used one, wish I had one. Used to have one as a kid, but you throw the yo-yo down, comes up, throw it down, comes up. And this is a little snapshot of a window. You see the height of a yo-yo is in inches, 10, 20, 30, 40, and it's seconds. So after 1.4 seconds, the height is 22. Then it goes down. After 2.05 seconds, it gets down to 10. And then the yo-yo comes back up to your hand, and there we have the same height, assuming your hand's in the exact same spot. Isn't math perfect? So, we're going to have some questions about this. So it says how much time, remember, these are x's, so time has to do with our x's, to complete a cycle. Well, it goes through, and this looks like a sine curve or a cosine curve. It goes from 1.4 to 2.7. So really I'm going to go 2.7 minus 1.4, pretty simple actually, 1.3 seconds to complete a cycle. How long is the string? Well, we're talking height, so that's our y value, and you can just look, again, perfection. The height, the maximum height is 22, minimum height is 10, so we're going to go 22 inches minus 10 inches, so the string must be 12 inches. Not bad. Okay, so there's a little warm-up. As you can see, this is nowhere near as difficult as the first lesson. Okay, problem number 2. Number 2 is supposed to be a review. Now, it's kind of like a guilt trip we throw on you, but every time we say parent function, in a way we're kind of like saying, you should know this. But I think that's true for y equals x squared, it's true for y equals the square root of x, it's true for y equals x cubed, and a few others. But this parent function isn't one that just sticks with you because you haven't worked with it a lot. So what I'm going to do is take a whole bunch of values and just show you what I did. I just grabbed a whole bunch of these x's. I'm going to use a black marker for the parent function. My point is, they're going to give you a problem like this, and they're going to say graph it, with the expectation that you notice, like, oh, this is a reciprocal function, which takes you to here, which if you have to, you can go to here, but over time, you're supposed to just know what it looks like. But I'm going to take another moment and just explain why it looks the way it does. So simple, if I put negative 4 in there, negative 1/4 for y. Negative 3, negative 1/3, negative 2, negative 1/2, negative 1, and I get negative 1. Now 0 is not possible, which is significant because that's telling you that there must be an asymptote. And remember, that can be y equals some number, and that can be x equals some number. Y equals some number is a horizontal line, x equals some number is a vertical line. With that being said, plugged in 1, got 1, plugged in 2, got a half, and so on. Now, if I only plotted those points, negative 1, 1, and then negative 2, 1/2, negative 3, 1/3, negative 4, 1/4. You can kind of see where it's trying to go, and, oops, okay. Notice I wasn't even considering the negatives. So those would all flip. So negative 4, what was I doing? Okay, negative 1, negative 1. Negative 2, negative a half, negative 3, negative a third, negative 4, negative a quarter or so. And this is what it's supposed to be looking like. So you can kind of see, well, maybe it goes this way, maybe, where does it go? That's where these little guys need to really come into play. So if I put something just less than 0, heading in the negative direction, it'd be negative 0.001. Why did I pick that one? I don't know. But that's just the same thing as negative 1 over 1,000. Flip it, and I get negative 1,000 for my y. So if I went barely to the left of the y-axis, or x is negative 0.0000001, nope, 001, it's going to go way down there. So you can see this is going to come like this. Here's my y-axis. You can kind of pick up on what's going on here. So now I'm going to go 1, 1, and 2, 1/2, 3, 1/3, 4, 1/4, and we can kind of say, oh yeah, it's coming back to me. Now to make sure we know that it doesn't cross this, first of all, we know that x can't be 0, so it can't cross the y-axis. So what happens? Well, I plugged in 0.001 to there, flip it, I get 1,000. So it's negative, or positive 0.001, and it's going to go way up there. No way can I actually show you what goes on, but it goes up forever. So there's the parent function. So the question is, where are the asymptotes? Well, for this one, it would definitely be my y-axis. So that would be x equals 0, and it would definitely be my x-axis. So that's y equals 0. So with that in mind, this is kind of like the center of the whole drawing. So what does this do? Well, if you understand the parent function, this should be a piece of cake. This is going to be up 1, that's going to be left 2. But wait a minute, everything moves left 2, up 1. So that means the center, and I'm going to go left 2, 1, 2, up 1 is right there. So really what that did was, it moved my y-axis here, it moved my x-axis here, and I'm going to do my best to just duplicate it. Remember, from the center, 1, 1, so from the center, 1, 1, that's kind of a significant point there. And there it is. Same thing over here. This is -1, -1. It's kind of a locator point. So from here, left 1, down 1, and so I know it's going to look like this. So sometimes they'll have you graph it. Sometimes they'll just have you talk about it. Left 2, up 1. A lot easier just to do that, but you should be able to graph it as well. All right. Let me pause it. Go get a snack. Okay, and you guys are getting used to this pre-calc curriculum. It's kind of just everything thrown at you. So now we're going to do some solving. Now you've done a million of these, but the little clue I give my students is when you solve this, see, a lot of students might look at this and just go, oh, x is 7. And then you kind of forget the other half of the world. What are you talking about? Well, bada boom, bada bang, do the right thing. So it's not just 7, it's plus or minus 7. So I'm using that example to at least get you in the right algebra mindset, because this is going to be algebra and a whole bunch of trig. So here we go. You got that situation. Well, notice it's cosine squared. Think of that as just like x squared. Now, I don't want you to be confused. This represents the angle. It could be theta. Maybe if I used a theta, that would be better. But they'll use x, they'll use y. It just represents an angle, and that's what we're trying to find. We're trying to find all possible values. That's the key. So I'm going to get started by dividing by 4, just like a basic problem. Notice, well, not notice, but I need you to know that that theta is not being squared. It's cosine squared. So keep that in mind. Divide by 4. So I get cosine squared theta equals 1/4. Same as this. Bada boom. Think of cosine squared as like x squared. Don't worry about the angle. Bada boom, bada bang, do the right thing. So I get cosine of theta equals plus or minus 1/2. We got to find all the possible areas where this is true. Well, if you recall, all students take calc. Where is cosine positive and negative? All 4 of these quadrants. What is this telling us? Well, cosine is adjacent over hypotenuse, so they're telling you the adjacent side is 1, plus or minus 1 actually, and then the hypotenuse has to be 2. Remember, our hypotenuse is always, always, always positive. Don't ever think of your hypotenuse as negative, because that's your spinner. So with that in mind, where can I draw a picture resembling this? Well, my adjacent side is always, always, always my x-axis. I don't know if you've ever picked up on that. So I'm going to make this 1, and then I'm going to make my spinner twice as long-ish. So think about that. If that's a 1 and that's a 2, you should immediately go, wait a minute, I recognize this. This has to be a 30. I know this is a 90, making this a 60. Now is cosine in this situation 1/2? Yes, 1 over 2. Adjacent over hypotenuse. So 60 degrees, or pi over 3, is one of my answers. Am I done? No, because the same thing happens over here. But look at -1, 2. Yes, these are the square root of 3's. But I'm not worried about this because I'm not dealing with sine. Well, that just means it's the same thing over here, so that's 60. Because this would give me my -1/2, -1 over 2. So how far did I spin my spinner? I spun it 120 degrees to get my 60-degree reference angle, which is just 2 pi over 3. But the same thing can happen here. So this is, again, -1, this is 2. My reference angle is 60. How far did I spin my spinner? 180 plus 60, which is 240 degrees, which is double this, so I'm going to double that, which is 4 pi over 3. In the last place that can happen, again, now my adjacent side's positive, hypotenuse is 2, and this is my reference angle, so I'd have to spin my spinner 300 degrees, which is just 60 times 5, so I'm going to multiply that by 5, so 5 pi over 3. I've got 4 answers. Now, if they tell you to put in radians, put it in radians. If they don't care, leave it in degrees. Just pay attention to the instructions. All right, so let's go on to this tangent problem here. Well, I don't have to divide anything because there's no 4 or 8 over here, so I'm just going to go right to it. Bada boom, bada bing, do the right thing. So I got tangent of some angle is the square root of 3. Now that's weird looking, but understand the square root of 3, if we remember our rules, x, 2x, x squared root of 3, it's very likely that we got a 30, 60, 90 in play. Look for those clues. Well, and the other thing is, I forgot the plus or minus. Back to this. All students take calc. Well, tangent is plus or minus everywhere. So we got to investigate all quadrants. But what is tangent? Tangent is opposite over adjacent, TOA. So in a way, they're telling you the opposite is plus or minus the square root of 3, and the adjacent is 1. Now, we got to be careful with this plus or minus thing, and also the fact that the adjacent is 1. Now remember, the hypotenuse has to be positive. What I'm saying is, this negative could float down to the adjacent side. So let's take a look first at the easy quadrant, quadrant 1. Let's try to draw a picture with this situation. So my opposite side is the square root of 3. Let me make sure I wrote this problem down right here, guys. Okay, so just to be really honest with you, I'm such a visual person, I need my 30, 60, 90s drawn perfectly, and this one just messed with me, because if this is 1, side opposite my 30, then my side opposite my 60 has to be the square root of 3, and this is looking like a 30 to me. That's why it threw me. So everything's good. I just have to be more careful with my drawing. So, whoa. Yes, okay, man, oh man. So my opposite side is the square root of 3, and that makes this my 30, that makes this my 60, that makes this a 1. Yes, this is a 2, but they want to know, where does this happen? How far do you have to spin your spinner to create that story? Well, I have that story right here, opposite over adjacent. So again, 60 degrees is one of my solutions. However, it's plus or minus the square root of 3 over 1. So if I investigated that same drawing over here, square root of 3, -1, opposite over adjacent, I would get a negative square root of 3. So I'm like, yep. Now do you notice these answers are reflecting the answers from the previous problem? And so then I investigate this. I got -1. and then I got negative square root of 3. Opposite over adjacent, negative over negative would give me the positive square root of 3. So this 60-degree reference angle is also true. Then I investigate this. This is 1, this is 60, this is my 30, this is my square root of 3, negative, opposite over adjacent. So that 60-degree reference angle is also my answer. So what are all my answers for x? Well, to create that story, 60 degrees. To create that story, 120 degrees. To create this story, 240. And to create this story, I'd have to go 300. I'm going to save your time and not convert those to radians. So, got one more thing to show you. Probably going to need a part 2 on this.